who is Salwa Mohammed, and I will share my screen.
Thank you.
We have here.
Okay, I'll just throw a quick link in there for. So we're going to go from grade 1 to calculus. That is what math can do. So I have been teaching. So I started university calculus teaching. This is my second year. 8 years in K-12 and 20 years total of teaching. We start with a product rule in derivatives in calculus. So yeah, go ahead. Okay, go to the next one. Right, and we'll go to the next one as well. Yeah. So I started off, put this up, and I found my students stuck. We're doing product, quotient rule, and then we were able to extend this to chain, integration by parts, and u-substitution. But when I start product rule, they were like, do I start with this one or that one? Does it matter? What do I start with? So go ahead to the next one. Thank you. So I'm like, okay, I'm going to draw a grid. So like a plus sign. We're going to put the factors on the left side. So the first thing I see, x squared plus 4. All right, guys, let's go. We're going to write x squared plus 4 in the factor. Then I see another factor. So I'm going to put that below it, 2x power 3 minus 1. And I'm like, all right, guys, everyone, what's the derivative of x squared plus 4? And
2x.
Yeah, I've gone through this so well. 2x, very good, good job, thank you. And then I ask, all right, what's the derivative of 2x power 3 minus 1?
6x squared.
6x squared, excellent. So let's write that down. Everyone, we want to always start bottom left. So I kind of start over there. I remind them because I know when you start doing this for every other method, this will start working. It'll start working for you. We draw an arrow, 2x power 3 minus 1. So we're going to draw arrow across. Go ahead, Saranita. Thank you. And then we remember that that's the first arrow you draw. Now draw another one on the other side. Cross product, multiply, and that multiplication on product is what? Repeated addition. So I go back there, connect it to that, and say, so this is going to be a plus sign. Remember the first arrow you drew? All right, guys, everyone, when I have my students, that's the first thing you write down. The 2x power 3 minus 1 with the 2x. So go ahead, Saranita. There. And then it was read off the grid. It was just read off for them. They're like, oh, okay, I'm kind of getting hang of this. I can do write my factor, derivative, cross, always going from the bottom left up. And then I'm reading off my answer. I didn't push them to add, open this bracket out, nothing. I just want to see product rule done this way. All right. Then can we do quotient rule? The same exactly. All right, let's try that. The first thing you see is 3x squared. So where would I write 3x squared? In the first box that I see. And so that was easy to transfer. X plus 5 goes below. All right, reminder, tell me again, where did we start? Where do we start? Bottom?
At the denominator.
Oh, no, but we didn't do the derivative. All right, let's do derivative. Help me here. What is the derivative of 3x squared?
At 6x.
6x, and that goes in the derivative box. And I've already done that. So what is the derivative of x plus 5?
1.
It's going to be 1. Excellent. And now remind me, where did we start?
Okay. So at x plus 5.
We started at x plus 5, the bottom left.
Right.
And that's why the quotient rule works so well here.
Right.
And we have
Times
the first
6x.
arrow. Go ahead, Saranita. And the second one. And you're doing quotient. Isn't dividing repeated subtraction? So I'm like, oh, remember your minus sign. And read it off. The first arrow you drew, just write it down. The x plus 5 goes with the 6x. Don't forget the minus sign. Why? And then you kind of remind them over The x plus 5 squared, we remember that, and you can always go back and explain why does quotient rule have x plus 5 squared. But the grid method really started to work for the students. I was able to extend this to chain rule, and that's on the website. Did integration by parts, which was interesting, and with u-substitution. So I'm like, awesome. We're doing 5 things. Same grid, start the same way, always find the same derivative, and always start from the bottom. And this started to work. Consolidation. When I went back to check research on this, 1985, someone did a grid method, but they only put it in integration by parts called IBP. And I was able to I was able to take my method, connect it to that research, and then extend it out. So next slide is just for you guys to try. Chats in the any answers in the chat, and I'll open that as well to questions. The other methods, we don't have time, but of course it's on the page. What I would love is for someone to try and tell me where this is breaking for them. That's all I need. It's not like whether it worked, awesome, but if it doesn't work, and where are students getting stuck? Or as a student yourself, where are you getting stuck? If you ever even tried this, that's what I would love to know. So yes, this would be derivative. Reminder, where do we start? Oh yeah, we started at cross, and then write your answer down. So if we're okay with time, Sayanita, and if anyone wants to do a derivative question in the afternoon, I'm in the middle of the night. If anyone, I'm okay with it. If not, we can go to the next slide, just for final answers also.
Okay.
Yes.
Okay. Yeah. Okay.
Thanks. So yes, that's what I wanted. I wanted to see if anyone has a chance to try this in your classrooms this autumn. And there's a quick form in there that says, this did not work because my students actually told me something else. So I've had this for 6 years now, and I have my own, whatever the students were telling me, but I have not had the chance, I haven't heard from more calculus teachers and see where does this really break? Just this idea of just drawing a grid, too much work? Is it extra? Is it a tool that works for some of those days? We don't know yet. So that's a mystery for me to find out. Thank you so much.
Thank you, Salwa. Questions for Salwa?
Oh, I just want to tell you that I do things like that. I make little diagrams also, and I often label them like U and V and U prime and V prime and things like that. And I find that the students who actually use it do fine, but there's always students that want to do it their way and it's wrong and they're resistant. That's where I've had the resistance.
True. I've always had 2 groups. I've got, the high school students that I taught this, and they had never seen this before. I had 70% of them use it and 30% going back to a tutor and doing a textbook way of product rule and quotient rule. I'm like, that's okay. I don't want your feet in both boats. Please pick up one of them and master that, and then bring that to the classroom. Plus, please show me steps. The university is a flip. I'm finding university students hesitant because they've seen this method before, and about, I'd say 40% of my students took the grid method and said, whoa, I have not seen it done that way before, and liked it. But they're reluctant. They're like, I don't want to learn a new way. And I'm like, is it a new way? Or yeah. So yeah, that's just mine. It'd be nice to hear from someone else who tries it, like you're saying.
I like the arrows, and I haven't done that. I do like having visuals, so you gave me some good ideas. Thank you.
You're welcome.
Thank you, Salwa. Yeah, it's really interesting. When I usually teach calculus over the summer, so next summer I will try this out and let you know how it goes. Thank you.
Thanks.
Okay, so if there are